Oh, hey, thank you for joining. I'm glad that you came here. What is that? What am I doing? Oh, I'm doing some shift register stuff. What? Oh, I did that before. So I see you've been here before in my channel. That's great. In case you haven't, I'll leave a card right over here that you can see it. But you're right, I did that shift register before, but that was with Arduino. This time around, I actually want to show you how to do something with a .NET microcontroller. This is coming from the Meadow Foundation, and it's a .NET C# microcontroller that you can actually run some code in it, writing C#. So what I think we'll do now, I'll show you the boards and some of the code and how great that microcontroller is, and I'll leave you some links in the description below. And if you have any questions or concerns, also leave me some comments. And maybe you can even write what you will do with this as the video progresses and you get some ideas. So come in and let's dive in. All right, guys, so here we are in front of the computer, and I'll show you how we can actually use the Meadow microcontroller and manipulate a shift register. Basically, a typical, kind of like a blink LED, but a little bit more fun. We'll do that in two steps. The first step is if you wanted to write it by yourself, and you wanted to write your own code for the shift register. Another one is to use the foundation itself and the wilderness labs code to actually use the shift register that they created. So what we'll do, we start Visual Studio 2019. They're still in beta, and they're working on actually a plugin for Visual Studio Code as well. So for now, it's just Visual Studio 2019. We'll create a new project, and the link in the description for the Meadow, how to install and such, I will leave it in the description, and I will explain to you how to set up your environment for it. You can search either from here and find the Meadow application right over here, but I also have it as the recent one. So if we'll start over here, click next, we'll click, we do shift register test, and we create. That will automatically will start you a Meadow application with default code in it. I'll not go into too much detail about it, but you can explore by yourself, or leave me comments in the description below, in the section of the comment section below, and I will answer you any questions you might have. They also actually have a Slack channel, so you can join there as well. So the Meadow app, and I probably pronounced that incorrectly, so please let me know if I'm saying it wrong. It comes with the default code already to manipulate the RGB LED that is on the board. So we will actually remove all of this, as we don't need that right now. Okay. And one thing that I do want to do is actually copy this file. It's a file that I created for the shift register. And I will leave a description for the GitHub repository as well. So check the description below, and we'll include that file in here. And what that files allow us to do is really, you can use it not just here for the C# code. You can actually also import it and translate it to your Arduino code or anything like that. So all that it's actually looking for is the device itself, and then data pin, latch pin, clock pin, and clear pin up and output enable. Those are really the main 4 or 5 pins that you need on the shift register. The data pin is where it's either high or low, and it tells it if it needs to shift a 0 or 1. The latch pin is actually sending that information. The clock pin is only sending that information when it's high and not dealing with that when it's low. And then you have the clear pin, which is optional. It's if you want to clear the whole outputs, and then output enable is basically telling it if it's going to be off all the time, or you can manipulate the pins themselves. Like I said, I have a card somewhere on this video that will take you to my previous video that I explained exactly how the shift register, and specifically the 74HC595 works. So what we do over here, we're telling it what pins it is, we're setting them up, and then we can actually send data either as a bit or as a byte, because we have 8 outputs. I didn't go into more detail. What if you want to chain it, etc.? You can change the code accordingly. One thing you can do over here is actually sending it as a string, and then it will go through that string and continue pushing 0 and 1s, and that's what's kind of like a way to move from having multiple bytes. The update is really running the latch itself to send those bits. Clear, it's actually making sure that the clear pin was set up. The same thing is for the disable and enable functions, looking on the output enable. So if we wanted to go and write the code for it now, we will need to create a variable. So we will call it shift register. We need to create a variable with this type. And we call it register. And come on. Should be able to. Oh, that's why. It's the wrong namespace because I copied it from something that I already had. So now we'll recognize it. And just a second, let me go back over here because there's a specific function, which is the constructor itself that all the code will go in. So we'll do over here the shift. Let's call it register, and then we'll create a function, private void initializer or initialize, and this is where we'll initialize all our components. So we can do register equal new shift register. We'll send it the device, and the device comes from the app itself. It's a global variable. And now all the pins that we want actually to output. So in my setup, I'm actually looking on the data as pin 15, the latch is pin 14, and then the clock is pin 13, I believe. Yes. And I will show like a small video on how everything looks like. So if we do device dot pins dot, and then you have the exposure over here for all of them. So pin 15, and we'll do the same thing, div dot pins dot D14, and device dot pins dot T13. And that in turn, if we go back to this code, it's actually generating an IPin, right? That's the variables that it's accepting. And then it calls another constructor, which is this one, when it's setting up all the ports. And it's checking if the clear and the output are being passed or not. And creating those as an output port. So now, as part of the initialization, we have the register. So we can now do what we want to do. So let's say we'll do a loop over here. Oops. We call it loop. Not existing, so we'll create it now. And it's probably, we'll do like private void loop. And then in here, what we want to do is, let's say we're going to want to go up and down on those 8 pins that we have. So one thing that we will need to do is a for loop And we can do var index equals 0. And you can see this is a typical C# code that you can write. So index is go from 0 to 8. So we need basically 8 different values. Or if we want to start with 1 over here, so like pin 1 will be on, and then pin 2 will be on, etc. We can do that, but really all we care about over here is to go up and down. So we can start from 0 because we need eight of them. So now what we need to do is we need to call register. We can spell register dot send data. And like I said, we have different ones. So we can either send the byte of data, and if it's a most significant bit first or not, we can send a bit, which if we look in the code real quick over here, the send data, where is it? Send data over here really breaks down the data itself into the bytes, and it sends that to the send data with the Boolean value. So one thing we can do over here is, if we think about it, we want the first light to turn, in the next iteration turn that off and send the second one. So if you think about it, it's the power of 2s. So the data that we can send can be a byte of math dot pow of base of 2, and the power will be of index. And that will basically should do that up and down. And after every one of these, we'll do red sleep of, let's say, 100 milliseconds. And then on the other side, we will want to do var index equal to 8, index is greater than 0, and minus index. And then we will do the same thing, send data byte math dot pow of 2, comma index, and then thread dot sleep of 100. And because we're saying that this is the loop, we'll say while true. So that is basically our infinite loop, which is the same thing in Arduino, that is basically running it forever. So that is, in a way, the code, if you're including this one as well, to run it. So let me turn on my camera over here so we can see what happens. So we have, right now I have two boards. We have this board, which I want to show with my code, and then this board will show with the foundation code. They're still going to manipulate the same LEDs. That's why I have 2 sets of wires. One goes from my board, my code, on pin 15 to 13, so 15, 14, and 13. The blue wire goes to the data. The purple wire goes to the latch, and then the gray one goes to the circle, the clock. And then in reverse, it's over here. So let me disconnect the power and ground on this board, and I will connect the USB. And now we're back here. Sorry for turning away from you guys. What we'll do, let's build this. So if everything works correctly, this microcontroller will control this shift register over here, and everything should be fine. and it will need to rotate and go up and down. Now, the nice thing about it here, because it's still Visual Studio Code, you can actually debug this the code if you need to, put breakpoints and such. Once again, go on the description below to follow the link on how to do all of this. So let's deploy this. And let me pin it over here so we can see what we're doing. Your console output will actually be here. Let's see if everything is connected correctly. So now it's actually deploying our .NET standard 2.1, I believe, and our C# code over here, compiles it, push it to the microcontroller here for it to start running. Sometimes it takes a little bit, so I might fast forward over here. All right, so the code finished. You can see launching application, and on the window, I don't know where, you can see that actually the LEDs are going back and forth. And that's really your first .NET code to go on the microcontroller. So I'll disconnect this one now. And let's look at the code if you were to use the foundation. So one thing we need to do is we need to go into the dependencies in GitHub and browse, and let's browse for the Meadow that I believe it is foundation.ics. And you can see part of the ICs, they have the IO expansion SN74HC595. So we want to install that. That's as a new Git package. So now, if we remove all this code that we had before, so I'll comment that out and comment this one out. What we can do now is say using foundation.ics.io expansion. I believe that should be it. And now we can use the X74 and call it register. So the way that their register is actually working is not actually going on a typical pins. It's using over here, or to see. Let me disconnect now this board from here, and I can connect this board to the power and ground because we don't need that code anymore. So it will be easier for me to show you. And let me zoom. It's hard for it to zoom, but the data, the latch, and the clock are now actually connected to the clock over here on the Meadow itself, and the MISO, and then pin 3. I'll try to leave you fitting the image, and it will be easier for you to see it. But you can see that the data, it's the blue line, it goes to your MISO. The yellow, which is the clock, is going to the clock on the Meadow itself, and then the data, or the latch, sorry, goes to your D3. So what we can do now in the initialization is we need to start initializing it. So we do register equal new register equal new. And now it requires the device, just like the other code. And we need to create a new SPI bus. So trying to remember how to do that. I think it's device that create SPI bus. And you can give it like the speed, but you can leave it also default. And the pin chip select, that's our device.pins.d03. And what was the last one? Number of pins. So if you have multiple pins, so multiple shift register, you can actually set it up over here. But like I said, it's in beta right now. It's actually working only with one shift register. The nice thing is all of this code is, their code is in GitHub, and you can actually see it and access it from there. So that's how you actually setting it up. And if we go now to the loop over here, so we can say now again, while true, and we'll do for a for loop, so var index equals 0, index less than 8, plus plus index, and we can say if, we'll do like that, register dot, and we can say, I believe, write to pin. So the nice thing about their code is I can set up a specific pin within the shift register to turn it on or off. So you don't need to worry about the number of pushes that you need to do of like 1 and then 0, 0, 0 to turn pin number 4 on. You can actually write to the pin itself. So it's requiring a pin, so we'll take a register dot pins, and we'll do all pins. And now this is giving me a list, so I can do the list of index. And what is the value? The value is true, right? So we want it high. Index, not, oh, oops. Okay. So now I turn the pin on, and we'll say if index is not equal to 0, that means that I'm not on the first one. I want to turn off my previous one. So we'll do register.pins.all pins in the place of index -1, and we'll send a false on this. And now we'll sleep for 100 milliseconds. And then we'll do the same thing just in reverse. So var index equal to 8, index is greater than 0, and then minus minus index, and actually needs to be less than or equal. And now we'll do register.write to pin, register.pins.all pins index, and say true. Then if index is greater than 0, we don't need to worry about the false. I don't believe so. Or do we? Actually, what we want to do over here is the current pin needs to be false, and as long as it's greater than 0, the previous pin needs to be high at this point. So index -1, and we'll do thread.sleep 100. And the nice thing is every loop we can actually say register dot, and we can clear. So that will clear anything that is on the register itself. So let's build this and see if we have any code errors. Okay, so now let me connect to the new one and we can deploy it. So now my camera is on. And because it's already been deployed once with the code, it should be faster. So you can see it's launching the application. And here we go. And something happened. So you can see actually there was an error. Index was out of range. No. That needs to be equal to 7, I believe. Yes, that needs to be equal to 7. So let's deploy that again. I'm sure there will be people screaming in the screen that it's going to be index out of bounds. But that's part of coding, I guess. So we can see it's still on over here, but as soon as it's running, it should clear the whole thing. So it's launching the application. There we go. And it goes back and forth. And this LED over here that you guys see is just the latch. So you can see how many times it's actually latching. It's flickering a little bit. I don't know if you can see it, and then it's flickering one big time. But that's really it, guys. It's .NET code running on a microcontroller. I mean, how cool that is. Definitely encouraging you to check it out. Go to their website, order it. I'm not getting any kickback on it and stuff like that. I really just want to share what I found and what I have with all of you makers, and that way you guys can enjoy. So if you like this video, thumbs it up. Don't forget to click on the bell and subscribe. It's really helping a lot for this channel, for me, and it tells me that you guys like what I'm doing. If you have any questions or any comments, leave it in the comments area below, as well as what would you do with that? I mean, here's a microcontroller that you can write .NET code. How would you use it in your home? What kind of IoT devices would you actually plug it in to it and use it? I would love to hear it. If there are any videos or anything that you would like me to cover, also leave comments below. This is for you guys. I love doing this. And I'm enjoying doing those videos. So let me know what you guys like, and that way I can, think about it and do it for you. All right, thank you guys, and I hope you enjoyed that. Bye.